Hey y'all, this is Mr. Mayer, and in this video we will discuss parallel lines with transversals. By the end of it, you want to be able to say, I can apply algebra and angle theorems to solve for missing angle measures created by parallel lines and a transversal. So our job is to find y and justify our answer. So we need to make sure we are explaining what we're thinking here. So here is our angle y. Now if I'm looking at the other information that is given to us, it really doesn't have to do with a y. I see that there's variables of x's in here, and then I just have a y kind of by itself. So our job here, we really want to start investigating and deciding which angles have relationships. If I look at y with this angle, there's not really a relationship there. If I look at y with this angle, those two they're supplementary to each other. They make a linear pair. But again, when I solve equations in math, I need to use the same variable unless I'm working with multiple equations at one time, which we're not doing for this stuff. So what we want to do, we've got some steps from your instruction. Our steps are, first of all, let's go ahead and decide where is or who is the transversal for this diagram. If I'm looking at the transversal, which of our lines intersect two or more lines, and I see that line C intersects both lines B and A, so therefore C is our transversal. Next question, are the angles interior or exterior? So if I'm looking here, again, y is kind of by itself. There's really nothing for us to set up at this time, but let's take a look at this angle and this angle. If I'm looking at these two angles, this angle and this angle right here, are these interior or exterior to the two parallel lines? You're always comparing to the parallels. Well, this is outside the parallels. This is outside the parallels. So these are exterior. These are outside of our two lines. Next, do we have an angle type? Since these are both exterior, again, we're just looking at these right now. I know we need to find y, but we're going to focus on these for right now. Is there a special name for these two angles? Well, they are on different sides of C. One's above, one's below, so they alternate. And they are exterior, we just said. So these are alternate exterior angles. Since these are alternate exterior angles, the next question is, what is the relationship for alternate exteriors? Alternate exteriors are always congruent. That's by the alternate exterior angle theorem. They're congruent, but remember, it's not always. It's only if the lines are parallel, and we see that our lines are parallel here. So last but not least, now we're going to set up an equation and solve it. So let's go ahead and get started here. We already know that's what's nice about your step process here. They're alternate exterior, which means they're congruent, which means that the measures have to be equal to each other. So your equation is just going to be setting the first angle equal to the other angle. So now we've done that, we just solve it like normal. To start this process off, I always recommend move the smallest variable first. I see this is the smaller variable than the 7. Right now it's being added, it's a positive 3x, so I do the opposite to move it to the other side. Those cancel. 7x's minus 3x's equals 4x's, and bring down everything else. Don't forget your minus signs when you have them. Next, I want to isolate my x. 4 is attached to it through multiplication, so I need to get rid of the minus 66. Again, it's being subtracted. The opposite is adding it to both sides. So we're adding it to both sides. If I add this up, I'm getting that this is 108 equals 4x. Last but not least, isolate the variable. There's an invisible multiply right here. The opposite of multiply is to divide. Through long division, if I were to work this out, I would get that x equals 27. Now again, this is not an angle measure. This is only the variable. Only x equals 27. So my job right now is to see, again, I started up here. I don't really have a relationship between this y and this exterior angle. They're not same side interior. They're not alternate interior. This one's in, this one's out. I do, however, have an old relationship, a previous relationship between the y and this angle. So if I were to find out how many degrees this is, I can figure out why because, look, they both together create a straight line. So they are supplementary. So I'm going to go ahead and plug in this 27 in x's place so I can figure out how many degrees that full angle is. If I work this out, multiplication PEMDAS comes first. 3 times 27, I get 81. Don't forget to add the 42. And when I add this up, I'm going to get that this is 123 degrees. So I know that this side, this angle is 123. Now I need to find angle y, and we said that those two angles are supplementary. So I know that 123 plus angle y, or the measure of angle y, is going to equal 180 degrees. They are supplementary, and I subtract to both sides. So in the end, I find that y is going to equal 57 degrees. Here we go. Thank you guys for tuning in. See you in the next one.